Hello, this will be part 2 for reciprocal of linear function, part 2. Alright, I'm going to introduce another type of reciprocal function for linear function. For example, there is 1 over x minus 1, right? 1 over x minus 1. So, what happens if you have x minus 1, or you have a case that fx equals to negative of 6 over 2x plus 1, right? For example, this type of reciprocal function, which is also a linear, right? A reciprocal of linear function, right? It's a linear function, and this is also a linear function, a number divided by a linear function. So at first that, you have to know that, very simple, alright? Okay, please listen. So, if you know that, you look at this one, you know that this is your output, your input, this is your output, right? So the output is depend on the input. So this is your domain, input is the domain, where x minus 1, you have to remember that the denominator cannot be 0, which gives you x cannot be 1, right? Without drawing the graph, you know that x cannot be 1. So now you know that domain can accept any value. From negative infinity to infinity. Suppose you can accept any value, but you cannot accept 1. Only one number you cannot accept, which is 1. So how should you do? So you have to tear up the domain, right? You have to split the domain that such that you don't include the 1. Open means you don't include the 1, and from 1 up to infinity can be any number except 1. Alright, very simple. So for this case also, you can identify the domain easily without sketching the graph. You look at this is your function. So you look at this. The denominator cannot be 0. 2x plus 1 cannot be 0. Understood? This is a reciprocal function. For square root function, have square root function, the property of square root function. For reciprocal function, this one cannot be 0. So x cannot be negative 1 over 2. Can be any number, but cannot be negative 1 over 2. Once you put negative 1 over 2, you are getting 0 here. So it means the domain of f means that the input domain refer to input, the x value refer to input, the x value. So then you say that negative infinity up to negative 1 over 2 union negative 1 over 2 up to infinity, because you cannot accept negative 1 over 2. As I said, you can rewrite this as a real number, that any number but cannot be 1. Or you can say any number but cannot be negative 1 over 2. So this was the domain. This is how you find the domain of a function, of a reciprocal function. So how about range, right? Range. So for this video, I'm not going to talk about algebraic approach. I will talk in a separate video about how to use algebraic method to find the range of a reciprocal function. So I'm going to use graphical approach in this video here. So for example, if okay, now I'm drawing the y and the x-axis, right? The y and the x-axis. So as you remember that fx is 1 over x, right? It will be in the first quadrant and the third quadrant. So when fx equals to negative 1 over x, there is a negative. This one will moving down in the second quadrant and the fourth quadrant, right? So at first, you must make sure the coefficient is positive, and this will be, if negative, it will be in these two quadrants. So very simple, you just have the basic. So 1 over x minus 1, you know that x cannot be 1. So it means at 1 here, you're going to draw a dotted line to tell that you cannot accept x equals to 1. X cannot be 1. This is the line x equals to 1. So as you see that this is a positive, right? It's the same as this. The coefficient for x is positive and this is positive. So if positive, it will be in the first and the third quadrant. So at this case, because the asymptote is here, so your graph going to be in this part and in this section here. Sorry. Alright, it will be here. Alright, it will be here. So they will intercept the y-axis as well. they will intercept the y-axis here because now they're already passing through the y-axis and nearer to the x equals to 1, but won't touch the x equals to 1. So to find y-intercept, you have x equals to 0, right? So you substitute x with 0. You see, this is your y equals to 1 over 0 minus 1. Then you have negative 1 here, right? So this is the graph. What's the difference between these two? The asymptote shifted, right? Shifted. So how to read the range? The range is, you see the graph. Along the y value, there is a value, right? There is a graph. But after this, you see that during the x-axis, the graph is break, right? Break. So this means that it's continuous. So means during y equals to 0, right? Y cannot be 0, right? So y cannot be 0 in this case. So you have negative infinity to 0 union 0 to infinity. This is talk about y. Range is about y. So you can accept all the value of y, but accept this line, which is y equals to 0, right? So this is the range for this function. Okay, let's look at how to sketching this graph. Okay, simple. You draw the axis. You draw the axis. You have y, x. The first thing that you should do is you should refer to the domain. It cannot be negative 1 over 2, right? Negative 1 over 2. X cannot be negative. So you put a dotted line here. This is your vertical asymptote, your asymptote. So, okay, now you have 1, 2, 3, 4. Section 1, 2, 3, and 4. To identify which section is this, where's the graph? Very simple, you look at the sign here, right? And this is positive, right? Positive. So this one negative. Negative. So in this section, section number 1, section 2, section 3, section 4. So it's 2 and 4. So you know it's these two, right? These two. So you know it's here. And followed by this one. Alright? Say we'll intercept y-axis as well. Intercept y-x equals to 0, right? X equals to 0. So when x equals to 0, try to see. If you substitute x equals to 0, you have negative 6 divided by 1. Negative 6 divided by 1, here will be negative 6. So this is your graph for negative 6 over 2x plus 1. So we look at the range, right? Range very easy. You look, where is the asymptote? I teach you the easy way to read the domain and range for the reciprocal function. So as you see that x cannot be negative 1 over 2, right? They won't touch this line. They won't touch this line. That's why you exclude the negative 1 over 2. How about range? Range, you look at, it cannot touch the x-axis, right? It cannot touch the x-axis, which refer to y equals to 0. Means y cannot be 0. So this is the same that negative infinity up to 0, union 0 up to infinity. Or you can write all the real number except 0. Because y cannot be 0. You see the graph is not touching the x-axis, right? Okay. Oh, that's all for this video. I will talk about the next type of reciprocal of linear function in the next video.